Today's talk is on preparing data and model features for machine learning with ease, speed, and accuracy. We've got a lot of cool stuff in store for you today. There's a lot to cover. I'm going to try and move as fast as I can. My name is Ajay Sharma. I'm a product manager here with the SageMaker team. I'm also joined by my colleague Charu Soren, who's going to be speaking about feature store and ground truth later on. Just a show of hands, we got any data scientists here? All right, couple, MLEs, ML engineers, platform engineers, data engineers. All right, really cool, awesome. Have folks here played with SageMaker before, used SageMaker Studio? A few? Okay, cool. So let's just get into it. We've got a lot in store today. I'm going to start off by talking a little bit about challenges you would face with data preparation. Just a little bit about myself before we get into it. I've been with AWS for about 2 years, working on the product team, on the SageMaker team, which is our end-to-end machine learning service. Before that, I used to lead a data science team for a small management consulting firm called McKinsey & Company, where I focused on insurance and financial services. And then we used to use SageMaker all the time. I fell in love with the product, and I got an opportunity to come here and actually help build these types of products. So, it's been a really exciting journey. We've launched some really cool capabilities. One of those is called SageMaker Data Wrangler, which we're going to talk about today. We're going to get into feature store and ground truth, and we'll get into what all those are and how you can use them. The first thing, let's just start off with kind of what is the overall machine learning workflow to set the stage here. Typically, data scientists are going from raw data, then you have to go through this whole data munging, data preparation, exploratory data analysis process to get your data set prepared to then go into feature engineering, model training, and inference. And so today's talk, we're going to really focus on the data labeling part, the data wrangling part, and the feature engineering part. It turns out, and I personally spoke to over 200 data scientists while building and designing Data Wrangler, which is one of the services we're going to be talking about. And one of the biggest pain points they told us was that data preparation takes a lot of time. Like, they spend the bulk of their time just doing data preparation, and they wanted a way to make it easier and faster. So data scientists told us, hey, it's time consuming, it's resource intensive. If I have a large data set and I'm trying to prepare it for training a model, I have to go and sometimes get a bigger server because my data is too big. I have to get a bigger instance. I need to use different tools. Sometimes I'm doing SQL. Sometimes I'm in Pandas world. Sometimes I have people working with R. It's kind of runs the gamut. And then next, once a data scientist is done preparing their data for machine learning, you then have to move it into production, which sometimes requires a whole rewrite of code. I've seen teams where they have to rewrite Python code into SQL. I've seen teams that have to go the other way around, and it becomes a mess. And then lastly, many common data preparation tasks require you to write a lot of code. So, we wanted to come up with an answer for that. And again, when you have to repeat this, many times enterprises are not doing a single data science project. They have teams, multiple teams, sometimes doing data science projects, and it becomes overwhelming to manage everything. So to help manage this entire process, we have Amazon SageMaker, which is contains a full suite of various products to help you with your machine learning needs. I won't go into everything that's listed here, but today we're going to talk about a few of those on the preparation side. In particular, Data Wrangler, which you can see on the left, ground truth, and feature store. So, there's a lot going on here. It's not doing an ML project, building a model, preparing data for it. It requires a lot of different tools and processes, and we have basically tons of different capabilities that help you with that. Today, we're going to talk about the first part, which is how do you process your data? How do you prepare it for machine learning? And to help answer that, we built SageMaker Data Wrangler. So Data Wrangler is an interactive tool. It's in the UI. It doesn't require you to write any code. And it's located within SageMaker Studio, which is our IDE for machine learning. Data Wrangler allows you to connect to your data, visualize it, understand it, prepare it, and then once you've done all of that, move it into production. And it all happens within a few clicks. So just to get started, we've got some screenshots here of it. The first step when you're doing data preparation, feature engineering, is importing your data. And so to import your data, you first have to connect to it. Today, Data Wrangler allows you to easily connect to S3, Athena, Redshift, Snowflake, Delta Lake, Feature Store, and we have a ton more supported data sources that are coming. So if you've got data there and you want to easily connect to it, it's literally a point and click experience. I will demo it to you later on in this presentation so you can actually see and get a feel for what it's actually like to use it. We also have a ton of support for a variety of different common file formats. So CSV, Parquet, we support JSON, JSON lines, ORC, and database tables. You can actually view and browse your databases on Data Wrangler. So this is just an example. We've actually built an entire file browser capability for S3 directly inside of SageMaker Data Wrangler, which we'll check out later. We also have a built-in SQL editor and SQL query interface. So if you have data on S3 and you want to use Amazon Athena to query it, you can actually go ahead and do that right from the UI. And you can see on screen a simple select star query is written there. You type it in, you click run, and it's as easy as that. You get your results of your queries. So once you've done the import step, you've browsed for your data, you've looked for it, you know what data you're working on, the next step is to actually start to perform what data scientists call exploratory data analysis. It's a technique called EDA. And basically what that means is you're going to explore your data. You want to learn about it. You want to check out, are there any anomalies there? Are there any issues with my data? What is my data trying to say? What is it telling me? What insights can I get to? So we have a full visualization suite inside of SageMaker Data Wrangler. And I'll show that to you in the demo as well. And what you're looking at here, for example, is one of the histograms that were generated with Data Wrangler without writing any code. And if you've ever had to generate visualizations using Matplotlib or ggplot or some tool like that, having a UI capability to help you with that actually makes a lot of difference. We've got advanced visualizations as well. So this is what we're showing here is an example of one of our visualizations. And this one is called target leakage. And so target leakage is just one of those things you want to check for when you're preparing your data set to make sure when you're actually going to train a model, you don't run into any issues that say basically, hey, I'm trying to predict something. You don't want to game the system by trying to predict something using data you don't already have. And so that's a simple way of trying to define this. What you're looking at here is a listing of all the features. So starting from arrival, delay to origin, and this is just a sample data set of flights. And on the x-axis, you can see predictive ability. And so the legend basically color codes each of the features and says, hey, if you're green, this feature is probably not highly predictive of your target variable or of the variable you're trying to predict. So you're safe to use it. If you get something that's has high target leakage, then you want to revisit that. You want to look at that and make sure you're not putting any logic that may be convoluting or confusing your machine learning process. So that's just one of the examples. And we have a ton of capabilities and explanations as well. So if you're not an expert in data science or you don't know what each of these things mean, we actually have built-in explanations for each of these visualizations as well. So once you've sort of explored your data and you visualized it, one of the capabilities we have are the built-in transformations. So I have raw data that I'm pulling into Data Wrangler. Now I have to prepare it for machine learning. So I can apply, sometimes I need to rename columns, sometimes I need to drop columns, sometimes I'll need to encode columns if I have categorical variables, and do other types of processing. If I have time series data, then I'll want to process that time series data in a way that I can use for forecasting or some other downstream ML task. So we have over 300 built-in transforms. Additionally, we have, so one of those, for example, is balancing data. So if you're working in an ML problem and you've got a binary classifier and you're trying to train a binary classifier on your data set, and your two classes are highly imbalanced. So a common example of that is fraud, credit card fraud. And the incidence of credit card fraud is super low, but maybe you have billions or trillions of records of valid credit card transactions, and maybe only 1,000 or tens of thousands of records of fraudulent credit card transactions. So when you take a sample of that to train a model, you encounter what's called highly imbalanced cost distribution. And so what this transform lets you do is basically rebalance that data set so that the representation of your minority class, which in this case is fraudulent records, is amplified so that your machine learning model can detect those and better train on them. So we have a few options for that. We have kind of random oversampling. We have something called synthetic minority oversampling technique, or also called SMOTE, which helps generate and augment your data set with synthetically generated examples. And all of those are right there in the tool. You don't have to write any code to do that. And if you've had to do that before, if you wanted to use SMOTE, for example, you have to go look for the library to do it. You have to find it, you have to install it. Someone has to now make sure this will work in production. It becomes a whole effort. And so all of that we kind of cut through and support with right inside of our product, inside of Data Wrangler. If there's a transformation that you want to apply that we don't support through our user interface, you can actually type it in. You can write the code out to do it and actually plug it right into Data Wrangler. So we support SQL through the Spark SQL context. So this whole thing is powered under the hood by Spark. We support pandas, so you can write your own custom transforms in pandas if you're used to pandas. And we also support PySpark as well. So you can write your transforms in any of those languages or libraries and apply them right inside of Data Wrangler. This one is just someone doing a simple SQL summarization of the data set right here. We just launched some new transforms for time series. So if you work with time series data, and we've heard from our customers that they do that a lot, one of the new capabilities we launched is time series. So we've got a whole catalog of various time series transforms that help you do everything from resampling. So if you have to, downsample from like a very high frequency data set to a lower frequency data set, if you need to create date time columns, if you need to reformat your date time columns, kind of all these common time series operations that you have to apply, it's all right here in Data Wrangler, and it's all available within the user interface. This one, as you can see here, it's someone creating a date time range column. And so what they're doing is they want to create one value per business day. And you can set the starting timestamp. So they chose January 1st, 2008. You can give it an output column name, and you just hit preview and add. And that lets you just add a column as easy as that. So figuring out how to do that would require sometimes Googling it, looking at Stack Overflow, reading some documentation, finding the right code, especially if this is something you haven't done before. We've got visualizations as well. So as I mentioned, this is one of the visualizations that we offer inside of Data Wrangler. This one is called STL decomposition. And so it takes a complex time series signal and it decomposes it into its different components. So one of those is the seasonality component, one of those is the trend, and one of those is the residual. So if you look at the trend and you look at the original signal, so the original signal is coming out of the top left, and it's really noisy, it's moving up and down a lot, and it's hard to make sense out of. And so when you extract the actual general trend out of it, you can see kind of what's going on overall and get a high level overview of what the actual signal is inside of that data set. One of the really cool features we also have is the ability to quickly train a model on your data set. So many of the data scientists we've talked to have told us, hey, I do all this work to prepare my data set for model training. The model training, model evaluation is almost like the dessert of the whole process. I want to actually see, hey, can we actually train a model out of this? Is the model out of this data? Is the data good enough to generate a good model? Is the model going to help improve the ROI of my business? So how can I quickly get a sense of, have I done enough feature engineering? Have I done enough data preparation to result in a model that's going to be effective for my needs? And so what we did is we said, hey, let's just let you do that in a couple of clicks right inside of SageMaker Studio. So we built this capability called Quick Model. And so what all you have to do is you tell it, you give it a name, and you point it to the label column. And the label column is just the column you're trying to predict. Under the hood, it's going to split your data up into a training and test set. It's going to train a model on the training set. It's going to evaluate it on the test set. And it's going to give you a full readout of the results of that model right inside the UI. So it's really cool. Under the hood, it's using random forest implementation. So if you know random forest as an ML model, very popular, very robust. That's what's running under the hood. And we're actually going to be broadening the choice and selection of algorithms later this year and early next year as well. So another really exciting capability. What you're looking at here is just a bar chart of the feature importance. So you can see the ticket feature and the name feature, predictive, some other features not so predictive. And then the other thing we have is as you add these steps to your data flow, so you can think of the process of, I start with raw data, I apply some transformations on top of it, and then at the end I export my results. So one way that most data scientists have to do this today is they have to stare at thousands of lines of code, starting from the raw data that gets imported, all the pre-processing exploration steps, all the transformation steps, and then finally there's a save to S3 or a save to some destination or sync area. So what we did is we said, hey, let's help you visualize what's going on. So instead of having to stare at 10,000 lines of code, you can actually just get a top-down view of everything that's going on. And so what you see here is there's 2 data sources being imported. There's a custom SQL transform being applied on the top, and then it's being joined with another data set on the bottom. So it's just a really helpful way to help visualize what's going on in your data set. And then finally, once you've done all that preparation, you want to export it out to a destination. So we support S3 today. So you prepare your data, and now you just tell Data Wrangler, hey, once you're done processing my data, store it to S3. So here you can see someone's added their S3 bucket and added it as a destination. And then once you've added your destination and told Data Wrangler where to store your data, all you have to do is now start a job to actually execute that entire flow diagram that you see there. And so what's going to happen is SageMaker is going to provision the compute for you. It's going to read all your data into that compute. It's going to execute all the steps you defined in your flow diagram, and then it's going to save your results to S3. And then when all of that's done, it's going to shut down all of that compute, and you're only getting billed basically for what you use, which is really cool because trying to do this on your own, if you've had to try and figure that out, is a very time-consuming and difficult task. It's not very efficient, and it's also not very cost-effective. So this is a really cool integration that allows you to leverage the power of SageMaker processing without having to actually write any code or figure out what containers to use or libraries or anything like that. It's completely low-code interface. And then finally, once you need to move this into production to run and execute this, you can actually integrate everything with our SageMaker pipelines capability, which is our end-to-end ML ops tool. So you can think of the data prep as just one part of the story. Once you do the data prep, you actually have to train a model. Once you train a model, you have to diagnose the model and assess the model. And then assuming everything is good, you have to deploy the model. So all of that forms one large concept, which we call a pipeline. And so you can take everything you've done here and embed Data Wrangler directly inside SageMaker pipelines. And so that's one of the really cool pieces that makes this really easy to use is, when you're done doing your data preparation and feature engineering, you just have to hand it over to your MLE or whoever's responsible for your MLOps and say, it generates the code that you need to integrate into your pipeline. So it makes the whole journey from development and prototyping into production really easy. And then, this feature is available today. It's inside of SageMaker Studio. So wherever SageMaker Studio is available, we're available, and it's priced per instance hour. So Data Wrangler, the UI runs on an M54 Excel instance, and you're just paying the you're just paying for that use of that resource. So I'm going to pause here. I want to show a really quick demo of just how to get into the tool, a little bit how to use it. So if you're interested in playing with this, you can actually jump in and try it out, which I'd really encourage you to do. So I'm just going to switch over to the demo, and let's give it a run. Cool. Okay. I just got to do this guy. Okay, nice. Make this big. So what you're looking at here is the AWS console. I'm logged into my account, and I'm just going to go into SageMaker Studio. So if you want, actually, and you haven't used SageMaker before, you just got to type in SageMaker here. Uh-oh, what's going on? No, failure. Let's see, let me refresh this guy. Okay, I think we're good. So yeah, if you've never used SageMaker before, you just go ahead and in the console, once you've logged in, you type in SageMaker and you can just click on SageMaker, and then it'll take you to SageMaker. As I mentioned, Data Wrangler is an application that runs inside of SageMaker Studio. If you've never run SageMaker Studio before, you'll need to set it up. It's really easy. It's a few simple steps. There's a quick start available for you to do that. I've already done that. So I'm just going to jump in. You can see I've got my domain. I've got a user profile, and I'm going to launch SageMaker Studio. So what's going to happen is now SageMaker Studio is going to open up. You can see everything's loading, and I'm inside of SageMaker Studio. And this is like our IDE for doing data science. It's built on Jupyter or Jupyter Lab. So if you've used Jupyter Lab to actually do data science before, it'll be really familiar to you. A lot of the stuff will look very familiar to what you've done before. This is our getting started page. I'm going to show you how to jump into Data Wrangler. It's really easy. You just click File, New, and then Data Wrangler Flow. There's a lot of other really cool features here, but let's for now get into Data Wrangler, and it's just going to load, and I'm inside of Data Wrangler. Cool. So as I mentioned, the first thing that you do when you do data prep is you have to import your data. So we support a lot of different data sources. One of those is S3, Athena. We support Snowflake, so you can connect easily to Snowflake. Databricks Delta Lake support via JDBC just launched, and Amazon Redshift. So all of those are there, ready for you to use, and it's really easy. I'm going to show you the S3. I think most people here are familiar with S3, and it's just a storage service by Amazon, if you don't know what it is. And I'm just, let me go back here. I don't want to go too fast. So I click on S3, and what you can see here are a listing of all my buckets. So I have a ton of buckets here. I'm going to just go into one of my buckets where I keep all my data sets, and it's just as easy as if you're navigating a file system. So I just went into a directory here called airlines. This is a data set of airlines from 2008. You can see this is a CSV file. It's about 200 megs. And I can preview that file right here. And so you can see like how easy it is to just use this without having to write code. If I didn't have access to a file browser, or I didn't have access to easily preview files, you're kind of doing this inside of a notebook or writing code. And here it's all right in front of you, and it's all visual. And so you can see I have a bunch of data here. It's previewing the first 100 rows. I've got columns in my data set. It looks like these are flights from 2008. I probably downloaded it from a data repository, and it shows the departure time, the arrival time of flights. On the right-hand side here, you can see the name of the file type, and as you can see, we support CSV, Parquet, JSON lines, ORC. We have a ton of other formats that we're going to be supporting, and you can actually browse all those. And what's interesting is some of these formats are not necessarily the easiest to view visually. So if you open them up in a text editor and you want to just try and make sense of it, it's not always easy to make sense out of. What we have here is just a really easy to use interface that shows you the data right in front of you. If you click on advanced configuration, you can change certain parameters on how you import your data. So if you've got comma delimited, colon delimited, pipe, tab, sometimes we see some of those frequently. You can change it. This one is CSV, so we're good. It's comma separated. And then over here, it's got sampling enabled. So if you've got like billions and billions of rows and you don't want to pull all of that right into Data Wrangler right away to do your interactive data prep always. Some people do, and you can actually do that as well. But if in case you don't, we have sampling enabled, which just creates a sample or a snapshot of your data set and pulls it in. And so once I'm good, everything looks good, I just hit import and it's going to pull it in. So right now it's performing a validation. And so one really cool feature of Data Wrangler is as you build out your feature engineering pipeline, it's going to auto-validate all the steps that you're doing. And it runs a check just to make sure everything is working. So in case you delete a step that's in the middle of your flow and it messes up things downstream, which has happened to, I'm sure some of us a lot, me as well, you want to be able to get a quick read on, okay, did I screw something up if I changed code in the middle of my workflow, and can I easily debug it? So it runs this validation for you. As you can see here, I pulled in my data set. It's this Airlines 2008 CSV. It gives me a node on the data types as well. So in case the data types are not what I want, I can actually change them here. So I can say, hey, year, okay, it's a long, that's fine. If I want to change it to something else, I can actually do that here. I don't think I need to do that. So we can go in. And so when I clicked on edit data types, what you're taking into is another view. And so this view is actually your data that you're working on. And so I can scroll through my data, I can see it. And then on the right-hand side are all the column names on my data and all the types associated to the data. Everything looks good. I'm going to click on that back button. It takes me back into this flow view. Let's say I want to add a step. I want to drop a column, something really simple. So let's see, let me go back here. You click on this plus sign and you hit add transform. And so now you want to add a transformation. You want to transform your data somehow. So what you do is you say, hey, I want to add a step. You click on this orange button. And now you're taken into this menu of all of our different transformations that we offer. And there's a lot here. And so we've got the custom ones at the top. So if you want to actually write a custom formula, which is just a Spark SQL expression, you can do that here. If you want to add a custom transform, you can pick from PySpark. You can write it in Pandas. You can do a Python UDF, or you can do SQL using Spark SQL. So you have all of those available to you here. You just write the code in, you hit preview, and you click add. And that transformation's added in. If I go back, I've got a bunch of built-in transformations as well. And so, if I want to just say, hey, move, drop, duplicate, or rename columns in the data set, let's click on manage columns and let's just try to drop a column here. And so I'm going to say, let's say I want to drop the CRS departure time column. So let's see, I just type it in, it pulls it up for me, I click it, hit preview, and you can see that column's gone. So it's not in the data set anymore. That looks right. I click add, and that step has been added. So I've got the data source import, I've inferred the data types, and then I've dropped a column. If I go back, you'll see a new node has been added here, and that helps you keep track of the steps that you're adding. Obviously, that's a really simple example. I could do more sophisticated stuff that I talked about earlier. For example, if I wanted to balance my data set, I could pick a target column. I have to see if I have one here. It's binary, maybe canceled. Let's say if I wanted to predict if a flight's going to be canceled, for example. And then you could just pick the ratio that you want to oversample between the minority and majority samples. And you can see it's really cool. We add the tooltips here. So in case you don't know what these are doing, or it's not completely obvious, we actually give all the descriptions there. And you can pick the type of transform that you want to apply to. So you could do smote, you could do oversample, you can do undersample. You can pick the number of neighbors that's needed to generate the synthetic observations. and you just click preview and add. So this one takes a little time to run, so I'm not going to run it here, but you can, I really encourage you guys to try it out. And then also, one of the other things I wanted to talk about is the analysis. So if I go, you can see two tabs here. There's the data tab and there's the analysis tab. Analysis contains all the visualizations we offer. So we have a ton of different visualizations here. Everything from generating a bias report in case you want to detect bias in your data set. And that's using SageMaker Clarify, which is another one of our many features that we offer inside of SageMaker. You can actually write your own visualization in here. So if you've got code, you can just copy and paste that code in here and it'll visualize your data for you. If you want to do something like look at feature correlations, we've got that as well. And even just simple things like, let's look at a histogram on my data set. And I just want to look at, let's say, I don't know, arrival times and see, hey, like how are arrival times distributed in my data set? So as you can see, it just generates a histogram for you. And it's as easy as just clicking around. I mean, you don't need to write any code here to do any of this. And the really remarkable thing is you don't need to write code to do things that are like, just quickly train a model for me, which is a whole process generally, or detect multicollinearity in my data set. So all of those are here and they're available for you to try out. And I really encourage you all to try it out. I can, I've previewed that visualization. I'm going to save it. And now it's registered here in my catalog of visualizations. If I go back and click on this button, you can see now there's this little badge over here that tells me, hey, you've transformed your data and you also have a visualization here in case you want to keep track of it. So the whole thing, this whole flow view helps you keep track of everything. And then, once you're done building this out, and we've seen users build out really, really complicated and elaborate feature processing pipelines, you can actually go and you can add a destination and say, hey, once I've processed my data, and this could be billions and billions of rows of data sets, thousands of gigabytes, terabytes of data, and beyond, you can process with this easily. You just tell it, you choose where to save your data so you can actually browse. Let's pick a destination. And once you've done that, you just click run job, and it's going to run this whole flow that you've created. And it's going to, like I mentioned earlier, provision those instances, read them in, process that data, and then save those results to S3. So that's it for the demo here. I'm going to just jump back. Now, so as you can see, like it's a really easy tool to use. It's inside of SageMaker Studio, and it's really powerful. So one thing I want to emphasize is it's a tool that, and so my colleague here is going to join us to talk about feature store in just a minute. But it's a tool that you can use to process your data without having to write any code. But it's also really robust and really powerful. So it's got simple kind of easy, typical transforms that you apply in your data set, like deleting columns, renaming columns. It's got sophisticated ones like rebalancing, like time series analysis. It's got visualizations. So it's a really rich and powerful tool, and it operates pretty much on any scale of data that you can throw at it. And we've seen customers do really, really creative things with it and generate some really powerful insights. So that wraps up the data Wrangler side. Once you've sort of prepared your data set, you've created features and you've engineered your features, the next step is to move them into a feature store. And Charlie's going to tell us about that. It's a really exciting product, and I'm going to pass it over to her. Cool.
Hey, thanks, Ajay. Thanks for the great overview and demo for Data Wrangler. Hi, everyone. My name is Charu. I'm a product manager on the SageMaker team. And today I'll talk to you about SageMaker Feature Store, which, like Ajay mentioned, that it's a data preparation tool that not only allows you to store your machine learning features, but it also allows you to manage the end-to-end life cycle of your machine learning features. So let's look at a world where there are no feature stores. So here we are using an example of a financial services company. And we have multiple data scientist teams in a typical organization. And these teams are building different machine learning models. So in this case, as you see on the right, we have a fraud prediction model, a customer churn model, and a next best action model. And all these data scientist teams are building these models, and they are referring to data sources. And you can see on the right some of these data sources, which are credit card services. You have transaction data sources, and checking account services. And what happens is that each data scientist team is recreating the same features again and again. So for example, a feature like credit score would be used across all these three models. And since these teams are not talking to each other, they end up creating that feature 3 times. And the challenge with that is, the first thing is that you are spending a lot of time in creating the same feature. And the second is standardization. So one team may create a credit score that is on a scale of 0 to 100, versus another team might define their credit score on a scale of 0 to 800. And as you go and try to interpret the model and you see the output of that or the impact of that parameter, it basically is difficult to interpret what the credit score means in each of these 3 different models. Feature Store eliminates that challenge by allowing you to create features once and then store them in a central repository, so that each data scientist team can search and reuse the features that have already been created. So in here, you see that you create your feature engineering pipelines from each of the data sources once, feed them into Feature Store, and then all the models on the right refer to that same repository of features. Feature Store also allows you to use the same set of features for training. So you can query the Feature Store to create training data sets, and you can also use it for inference, and it delivers the inference output at low latencies. And when I say low, it's as low as single-digit millisecond latencies. Since you're also using the same features for inference and training, it also helps you minimize your inference and training data skew. So these are some of the capabilities of SageMaker Feature Store, and we'll dive deep into each of these as we go through the following slides and also in the demo. So let's look at a very high-level architecture of SageMaker Feature Store. So if you look at a feature store, the fundamental unit there is a feature group. And you can conceptualize a feature group as a table wherein each row is a record identified by a record ID, and each column is attribute of that record. And you have values for each of those attributes in the cells. So you can configure your feature groups as online only. And in that case, you use them for online inference or real-time inference. You can also configure your feature groups as offline only. And in that case, you use them for training use cases and to generate training data sets. In case your business use case requires you to do both inference and training, you can configure your feature group as online plus offline, which is the most common use case that we have seen with our customers. In terms of data sources and how you ingest them, you can use any of the streaming or batch data sources. For streaming, you can have Kinesis or Kafka. And for batch data sources, you can have something like an Amazon EMR job. And you can ingest that data into SageMaker Feature Store. The way it works is that if you are using any of our APIs, the data gets written to the online store. And in the online store, we only store the latest value of a record and replicate the history in the offline store. The online store is backed by DynamoDB under the hood, which is a key value store, and it also supports low latencies. The offline store is in a customer-managed S3 bucket, and you can use any of your querying tools like Athena or open source tools like Presto to query the offline store. So when the replication happens from online to offline store, we ensure that your online and offline store are always in sync and consistent. And like I mentioned, we only store the latest value of a record in the online store, and the history is stored in offline. So in this example, you see in the online store on the left-hand side, we have 3 IDs, ID 1, 2, 3. And with each ID, we have just one timestamp associated, which is the latest timestamp for that record ID. On the right side, we have the offline store. So here again, if you see, we have the latest timestamp for ID 1, which is T5, but we also have the historical timestamp values for ID 1, which is at T4 and T1. So that ways you have history in the offline store and the latest value of features in the online store, and the two are kept in sync behind the scenes by the feature store service. So how do you actually ingest the data in feature store? We offer an API called the put record API, and we also have the fg.ingest SDK function that you can use to ingest data in feature store. So with put record API, you can mention the feature group name and the feature values that you want to ingest into feature store. And with the fg.ingest function, you can use any processing job under the hood as well. So for feature engineering, we offer different options. You can either use SageMaker processing jobs and bring your own script, or you can use Data Wrangler, as was shown in the demo earlier. Once you have the recipe from Data Wrangler, you can actually choose feature store as a destination and output that data into feature store and ingest it. Finally, we also offer a Spark connector for feature store. So if you have any existing feature engineering pipelines, which are Spark-based, you can easily integrate them into feature store as well. So one of the key capabilities that feature store provides is time travel. So you can move forward and backward in time with feature store. And this is really helpful when you are trying to create or reproduce a data set as of a point in time. So feature store offers 3 dimensions of times. The first one is event time, which is user generated. So every time you write a record into feature store, you are required to create an event time. The other 2 time dimensions are API time and write time, which are system generated. So API time and write time always move forward, whereas the event time is based on when you actually wrote that record. So using a combination of these 3, you can actually do time travel and go forward or backward in time as needed. So now we have seen how to do time travel, how to ingest data into feature store, and a high-level architecture. So you have your features in feature store, but then how do you access them? So for offline store, what feature does is when you create or enable a feature group to be offline as well, we create a glue metadata catalog. And with the help of that catalog, you can use Athena queries to query the offline store and create training data sets. So in this slide, you see some examples where you are using simple select statements to create a training data set. If you want to read data from online store for real-time inference use cases, we offer 2 APIs. One is the get record API, and you can call 1 record at a time using that API. We also offer a batch get record API, and that allows you to query up to 100 records at a time across 10 different feature groups. So if you have use cases where you are trying to get data from multiple feature groups in a single request, you can use the batch get record API. You can also set up your inference in multiple ways. So we show here 2 patterns. So in the first one, you have a model hosted on an endpoint, and there's an app. So the app is only aware of the IDs that you need to do inference on, but it's actually the inference endpoint that does the feature lookup from feature store, because it has all the information about feature names and feature groups. So the benefit of this is that if your model changes, your application doesn't have to change. The other inference pattern, which we have seen commonly, is that your application is aware of both the ID that is coming in the inference request, and it is also aware of the feature groups and feature names that you need to look up. And the application itself does a lookup from feature store. Okay. So now that we have seen an overview of feature store, let's quickly, I'll do a quick demo to walk you through how it all works out. Okay, so we'll continue with the same financial services example. Here we have a fraud detection notebook, and we are in a Jupyter notebook right now. So with the Data Wrangler workflow, you saw how to launch Studio and get into the Studio console. And here we have opened a notebook in the Studio console. So before we get into getting data, creating feature groups, and ingesting data into Feature Store, I'll first walk you through the setup steps. And even before that, I'll walk you through what is the data that we are working with today. So we are working with two data sets. One is the transaction data set, which has the information about the transaction amount, the transaction ID, and different card types of a customer. And then we have the identity data set, which has the different IDs for a specific transaction. So in terms of setting up your notebook, you first need to get the Boto3 client and the Python SDK. In our example, we are going to use both an online and offline feature group since we want to demonstrate both real-time inference and training. So to set up your offline store, since it's backed by S3 under the hood, you will have to specify an S3 location, and you will also have to specify a role for that S3 bucket. So here in the first, I have already pre-run this notebook to save us some time here. So the first step is you import the Boto3 client and set up the Python SDK. Then you set up your S3 bucket for the offline store. I'm using the default S3 location here. It sets it up in US East 1. And then I'm also taking the default SageMaker execution role. So you can see that it assigns it an ARN right here. Then the next step is inspecting your data set. So in case you want to check your data set for any missing values and update it, or you want to do some one-hot encoding before you ingest your data in Feature Store, you can use this code to do that, or you can, just, if you feel that your data is already prepared, you can directly get into creating feature groups. So here we show a sample set of the identity data set. It shows 5 rows and 21 columns that are available. And then we also show how the transaction data set looks like. So how do you ingest data into Feature Store, which is the next step? In order to ingest data, like I said, the user has to define the event time with each record. So in this piece of code, we are appending event time to each of the records that are available in the identity and transaction data set. Once that is done, we use the Create Feature Group API to create a feature group. And as you can see here, since we are creating an online plus offline feature group, we are mentioning the S3 URL, and we are also enabling the online store flag as true. The other key thing to note here is that we are specifying what is the event time key that we have defined. And we are also specifying the primary key, which in our case is the transaction ID. And we'll use this key to join the two data sets later when we create a training data set. So it usually takes a couple of seconds to create these feature groups. And once these are created, you can use the describe or list APIs to see and confirm whether your feature groups were created. I'll quickly show you the UI view as well. So here you can see the list of all the feature groups that have been created. So in the current notebook, I created the identity feature group along with the timestamp. So it's today's date along with the time that it was created at. You can double click on this to see the details of what your feature group looks like. So as you can see, it provides you the details of what's the ARN, what's the S3 bucket path, and it also shows you the glue data catalog that is created underneath. If you want to see the schema definition, you can either use the Hive DDL commands, as I'll show in the notebook, but you can also see the schema, both the feature names and the feature types in the UX. You can also assign tags to your feature groups. So for example, if you want to specify whether this specific feature group was created for production or dev, you can define that. Or if you want to define the user or the cost center for a specific feature group, you can use tags to do that. We also have some sample queries that you can use. So if you want to do time travel, you can use the sample query generated. Or if you just want to view some of the sample data set, you can use these queries to do that, from the UX to view your sample data set. Moving back to the notebook. So with the describe API, you get all the detailed information that we saw in the UX in the notebook as well. So moving on, let's see if your data got replicated into the offline store as well. And before we do that, we'll also see how we can use the ingest function to ingest data into feature store. So we simply specify the data frame for identity data as well as the data frame for the transaction data. You can specify the max number of workers depending on the scale of data that you are ingesting. You might want to use a processing job or a EMR Spark job. In this case, we are just using the max workers and the kernel and CPU capacity provided by this notebook. So once the data is ingested, you have to wait for a while before it gets replicated into the offline store. And while we wait for the data to get replicated into the offline store, we can quickly check it for a specific record ID and see if we can retrieve that record ID from the online store. So here I'm using the getRecord API along with the feature group name to see whether, to check whether the data has been ingested in the online store. So if I run this, I get the details for that specific record ID. I see the different, the transaction ID, the transaction amount, and the different card type, so that I can make sure that the data has been ingested. If you want to check for both the feature groups, that is identity and transaction, you can use the batch get record API to do that. Okay. Then moving on, this shows the HiveDDL commands if you want to see the schema of your feature groups that you have created. So it shows, again, the different fields or different columns that are there in your data set and what is the data type for each of those columns. So here, the data is, in my case, the data is already replicated into the offline store, so we don't have to wait. But once the data is replicated and it's available in the offline store, you get this notification that, hey, the data is available. And you can move on to the next step, which is building your training data set. So in order to build your training data set, we are using an Athena query here, which uses the glue metadata catalog underneath it. So it's a select query which joins the two data sets of transaction and identity on transaction ID. So once you have your data set, you will also need to export that data set into an S3 bucket so that you can run your SageMaker training job to train your model. So in this step, we actually put the data set in, we are actually putting the data set into the new S3 location, and you get the S3 location here, which you will use in your SageMaker training job. So once we have created the data set, it is SageMaker business as usual. You use a SageMaker-based algorithm. In this case, we are using the XGBoost algorithm. We create an estimator and train our model. Once the model is trained, we deploy the model on a inference endpoint. So our model is run here. We deployed it on a we use the deploy command to deploy it on a hosting endpoint. And then once that step is done, we can actually use an inference request to test our prediction. So when you create the training data set, you can keep some data for control and some data for test. So we are using one of the transaction IDs, which is 3450774 in this case, to test our data. We use the getRecord API to gather the data from both identity and then in a separate getRecord API, we get the data from the transaction data set to create our inference request. So this is the output of our inference data set, and we use the predict function to do the inference. So in this case, as you can see, the output of the inference says that it's 80% likelihood that the transaction that we have picked is a fraudulent transaction. And you can check it back with your training data set to make sure that you got the correct output from your model. And finally, once you have run this, when you have done your prediction, we also have some cleanup resources. So you can create your hosting and delete your hosting endpoint, as well as the feature groups that you have created, so that you don't incur additional costs. So that's it on the feature store demo. And with that, it brings me to my next topic, which is the third tool that we have in the SageMaker portfolio of data preparation tools, SageMaker Ground Truth. So let's move on to that. Okay. So for some reason, it's not letting me move to the next presentation demo, but I'll give you a quick walkthrough of Ground Truth as well. So one of the challenges that we face in training large data sets, especially if you have use cases like autonomous driving, is creating data that has accurate labels and do that at scale. And what SageMaker Ground Truth helps you with is that how do you create these large data sets and create these labels with accuracy? So some of the typical challenges here are, first of all, how do you create these labels at scale? And the second challenge here is, how do you make sure that your labels are accurate? And then finally, it's a very time-consuming and resource-intensive process. So the way SageMaker Ground Truth helps you address these challenges is basically, you take your raw data, which could be in an S3 bucket, you put it in Ground Truth, and with what Ground Truth allows you to do is, you can select from over 30 plus different workflows, or you can also define a custom workflow. Post that step, you can select from a group of workers who can help you actually define those labels using the SageMaker Ground Truth assistive UX. And then finally, once the job is completed, you end up with a accurately labeled data set as well. So that brings me to the end of my presentation. Thank you for your time. And I'm unable to get to the slide today, but would be great if you can. Yeah, it will be great if you can leave your feedback. I had a slide which showed our email IDs, but we will be hanging out after the session here. So feel free to drop by, and we'll be happy to take any questions there. Thank you.